Okay, so we are talking about intervals of increasing, decreasing, and constant on a function. So we just talked about the most important things is when we talk about each interval. We're going to use parentheses for everything, not square brackets, and we're using the x values to describe. Increasing parts of a function go up from left to right, so they can be a straight line or they can be curved as long as they go up overall. Decreasing goes down from left to right, so down, down, down. Constant would be a horizontal part of the graph. So what we're going to be doing is looking at a graph and talking about the pieces and what each interval is doing. Okay, so here's our first function. This is a piecewise function. They've pieced together a couple of different things. So this just says identify intervals of increasing, decreasing, and constant. So what I'm going to do first is I'm going to label it on the picture, and then we will use our interval notation. So this first piece, it kind of looks like it's decreasing because you've got this down arrow. We have to cover that arrow up and go from left to right. So from left to right, this part is going up, so I would call that increasing up to this point. Then from here to here, it's going down, so that is decreasing. And then from here to here, it's going up again, so that's increasing. And then this last little bit that's horizontal would be constant. So just getting the idea of what we're talking about. Then the part that's a little bit more difficult is actually writing out the intervals where it's increasing, decreasing, and constant. So what you're actually going to write down is increasing, or I abbreviated INC for increasing. And I'm going to take all of the increasing pieces and write them as an interval. So this increasing piece goes to negative infinity up to here, which is -3. So from negative infinity to -3, it's increasing. And we use parentheses for each of these intervals because at the end, it's sort of in that U-turn where it's changing. So that point is not increasing or decreasing. That's where it switches. Our other interval where it was increasing was from here to here. What are those numbers? So here, this would be 1, and this one would be 4. So increasing from 1 to 4. So those are the two intervals that are increasing. Then we had one interval that was decreasing. So that's going to go from -3 to 1. And we always use the x values off of this x-axis and break it apart this way. And then we had one constant, which I did not abbreviate for some reason. That starts at 4 and goes forever. So we call that infinity. So this is basically what we're doing, is just telling the intervals from the graph where it's going up, down, or staying the same. Okay, so the next slide, you want to make sure you have right side up. It doesn't have any numbers on it. This is the way I'm using it anyway. So make sure that your graph looks like this. And we're going to do the same thing. We're going to go through and just label on the graph what's increasing, decreasing, etc. And then we'll make our intervals. Okay? So on this first piece, I like to cover up this arrow because that makes me think down, but that's going to the left. We want to go from left to right. So this is going from negative infinity up to here. It is increasing. From here to here, it's going down. So that's decreasing. From here to here, it's going up. So increasing. Then it goes down again. Decreasing. And then there's a little piece that's increasing and a piece that's decreasing. This one doesn't have any constants, and that's actually pretty normal. Most functions don't have any constants. So the easiest way to write this with the interval notation is just to have two lists. We'll have a list for increasing and a list for decreasing, and I did abbreviate that a little bit. So we'll just go through and do all of the increasing intervals and then the decreasing. So increasing goes from negative infinity up to 1, 2, 3, 4, 5. This would be -5. So negative infinity to -5, it's increasing. The next increasing goes from -3 to 0. and the next one goes from 2 to 4. And we're just assuming that everything on here is labeled as 1 unit because they didn't tell us anything else. So that's all the increasing. We just go down and write the decreasing. So this one goes from -5 to -3. This one goes from 0 to 2. So remember, we're using these x values. And then the last one goes from 4 to infinity. So one of the things that I guess I should suggest is you go through, and if they haven't labeled everything on the x-axis, you might want to go through and write all of those in. We actually don't need to know anything on the y-axis for this. We just need to know that it's going up or down. Okay, so we're going to look at a special case, and then that's it. So here's a graph, and you do want to make sure that these numbers are upright. And there's something funky going on because we have some breaks. And so when this happens, we have what's called an asymptote. And so I'm going to draw that in with a colored marker really quick. So this graph does not cross the x value 2 at all. We've graphed some of these on the calculator, talked about that break. So a lot of times they will actually draw an imaginary dashed line there. There's another one at 3. The graph never actually touches it. It will get really close, but it doesn't actually touch that at all. So those are breaks in the graph. So just making sure that we know that. And those are called asymptotes. I'll actually write that on here because I don't think we've talked about that a lot. So asymptote. It's an asymptote. It's a Greek word. It doesn't make much sense in English. I forget what it means, but it's basically like a boundary line between this part of the graph and this part of the graph. And no part of the graph actually touches that line. It is actually a break. All right, so over here we have this curve. Make sure you're thinking about this is all going up. Now it's going up faster here than it is here, but it's all going up. So that's going to all be increasing. This part over here is all going down. It goes down very quickly and then it sort of slows down, but it's all decreasing. This part here we actually have to break in half. So we are assuming, if they don't give us this point, that that's between 2 and 3 and that that's at 2.5. It goes up until you get to 2.5 and then comes back down. So this side is increasing. This side is decreasing. So you do have to break that up. And then we can just make our lists. So I'm just going to do that down here. Increasing, decreasing. So we're increasing from -infinity up to 2. It doesn't touch 2, but that's why we're using parentheses. It's also increasing over here from 2 to 2.5. So since the 2 is where that boundary line is, that's what we use. Then it's decreasing from 2.5 to 3. And it's decreasing from 3 off into infinity.